Hello students, welcome back to all. In the last video, we discussed about the classification of periodic table, right? In this video, we are going to discuss about the chemical bonding. So, what is chemical bonding? And what is the necessity of to form chemical bonds or the atoms or molecules involved in the bond formation? So, what we have learned in the previous class, let us see. So we studied that the total number of 115 elements are arranged in the periodic table in the form of periods and groups, right? So this is the periodic table what we have discussed in the previous video. So now here there are some questions. See, in the periodic table we discussed that in the last group there are 18th group elements are there, noble gases. Generally, these noble gases are inactive, inert molecules, which means they are not involved in the bond formation or chemical bond formation. Why? Why do some elements are less reactive and why do some elements are more reactive? Some elements reactivity is very less and some elements are more reactive. And one more question here. So the formula for water molecule is H2O and formula for sodium chloride is NaCl. So why not HO2 and NaCl2? So this is one question. And third question is that, see, take the NaCl. NaCl means this is sodium and chloride. So when you shake this common salt, does it separate into sodium and chlorine? No, it doesn't separate. Which means here the two atoms, sodium and chloride, are being held together. So to answer all the questions, we have to know few points regarding this chemical bonding. See, by the end of the 19th century or the early of 20th century, the scientists knew about there exist three types of forces. The first one is called gravitational force, and the second one is called magnetic force, and the third one is called electrostatic force. See, because of these forces, they also knew about the existence of electrons and protons. For example, say here, take an atom. So this is the nucleus of the atom. These are the electrons around it. So the electrons are revolving around the nucleus. So this is the proton nucleus. So how the electrons and proton will exist? The existence of electrons and protons is also explained based on this electrostatic force. So it was believed that the electrostatic force was the cause of attraction between the atoms in a molecule. For example, take another atom. So this is one atom. This is another atom. So this is atom A and this is atom B. So here also electrons are there and at the center there is a positive charge is there. So this is the nucleus. So when the two atoms in a molecule come close together, the electrons of each atom experience the attractive force of the nucleus of the another atom, which means this nucleus is attracting these electrons. In the same way, this nucleus, atom A's nucleus, is attracting the electrons. Like this, there exists an attractive force. At the same time, there exists a repulsive force. In between the electrons, there exists a repulsive force, which means there are two types of forces are there. The first one is attractive force and the second one is repulsive force. So, because of these two forces, the strength of attraction or repulsion will be decide the bond formation. which means by depending on the strength of attractive force at the same time the repulsive force, the strength of the bond will decide. Which means if the attraction is more than the repulsion, then the two atoms will combine. If the repulsion is more, which means the atoms do not combine. Is it clear? So because of this repulsion and attraction, all it is about the electrostatic force. So the electrostatic force, due to the electrostatic force only the atoms will combine. And here we have to remember one more point. The nucleus and the electrons in the inner shells remain unaffected, which means, so this is inner cell, this is outer shell. In this, here also electrons are there, here also electrons are there. Here the nucleus of an atom and inner electrons will not affect, which means they are unaffected. When the two atoms comes close together, the nucleus and inner electrons are not affected. But the electrons in the outer shells are only will participate, which means the outer shell electrons are called valence electrons. These valence electrons of an atom get affected. It is very important point. Which means the electrons which are present in the last shell or the valence shell are responsible for the formation of bonds. So this is very important point. Is it clear? The outer electrons are only responsible for the bond forming. The inner electrons and the nucleus are not affected. So this is one important point we have to remember. And now let us see what is Lewis symbols or Lewis dot structure. The Lewis is a scientist. He explained about the Lewis symbol or Lewis dot structure, which means the valence electrons in the atom of an element is depicted in the short form by Lewis symbol or Lewis dot structure. For example, take an atom. For example, take sodium atom. So generally it is containing 11 electrons and 11 protons. So 11 electrons means configuration 1s2, 2s2, 2p6, 3s1. So these are the inner electrons. So the 3s1 only outer electron or valence electron. So the Lewis dot structure will be like this. Sodium is containing only one electron, which means only the valence electrons of an atom is depicted in the short form. So Na means, here Na means sodium atom. So the electrons here 1 means this is the valence electron. Is it okay? So take one more example. Take argon. So argon containing 8 outer electrons. So the 8 outer electrons or the valence electron will be represented in the Lewis dot structure in this way. Or take the neon atom. So neon also having 8 electrons in the outermost shell or the valence shell like this. Or the krypton. So krypton also having 8 electrons in the valence shell. Xenon also having 8 electrons. Or radon. Radon also having 8 electrons. Take helium. Helium is only having 2 electrons. So this way the valence electrons in the atom of an element is depicted in this short form is called Lewis dot structure or the Lewis symbol. Is it okay? So for example, take magnesium. So magnesium having 2 electrons. So this is not represented in the form of only dots. Is it okay? So now the electronic theory of valence. So in the chemical bonding, to explain what is the chemical bond, there were a number of attempts to explain the chemical bond formation between the atoms in terms of electrons. But the satisfactory explanation is given in the year 1916 by the two scientists called Kossel and Lewis, right? See, these two scientists do lot of experiments to explain what is the chemical bond in terms of electrons, and they gave the concept independently on the basis of valence, which means on the basis of valence they explain the concept what is the chemical bond. So they provided logical explanation of valence on the basis of lack of chemical activity of noble gases, and which lead to the proposal of octet rule. Generally we know that the noble gases means they are inert gases, which means they are not participate in any reaction. They are less reactive because of containing complete electrons in their valence shell. All the elements except helium containing 8 electrons in the valence shell. So due to that 8 electrons, they get stability because completely filled configuration. So now let us see how the electronic theory of valence is explained independently by the scientist Kossel and Lewis. So generally, if you observe, take the 1A group elements. So 1A group elements generally from lithium to cesium, we know that. And we discussed in the previous videos, they are containing NS1 electronic configuration, common configuration. For example, take the sodium atom. So sodium generally containing 1s2, 2s2, 2p6, 3s1. So while we are observing, it contains one electron in the valence shell. So to get the octet configuration, what the sodium atom will go? So it loses one electron in the valence shell and becomes Na plus. Na plus means it is unipositive ion. So sodium becomes sodium plus by losing one electron and becomes unipositive ion. Why it is losing one electron means to get the octet configuration. So Na plus configuration is 1s2, 2s2, 2p6, which means it is neon configuration. So neon is a noble gas. It contains octet configuration, which means it is more stable. So every atom will lose or gain electrons because of to get the stability. So this is what the chemical bonding. So the stability concept is explained on the basis of the chemical bonding. So now let us see the remaining. So take magnesium. So magnesium containing 12 electrons, 1s2, 2s2, 2p6, 3s2. So in the outermost shell it contains 2 electrons. So that is why to get the octet configuration it loses the last valence 2 electrons and becomes Mg plus 2. Okay, this is also dipositive ion. So why the sodium and magnesium loses electrons means to get the octet configuration. If you take the aluminum, it is also containing 13 electrons. Configuration is 1s2, 2s2, 2p6 and 3s2, 3p1, which means in the outermost shell it contains 3 electrons. So to get the octet configuration it loses the last 3 electrons and becomes Al plus 3. For example, take oxygen. So oxygen atomic number is 8. So it contains 1s2, 2s2, 2p4. Which means if you see in the valence shell it contains 6 electrons. So to get the octet configuration, it requires 2 more electrons. So that is why the oxygen atom will take 2 electrons and becomes O minus 2. For example, take fluorine atom. This is also, it is containing 9 electrons, means 1s2, 2s2, 2p5. So in the octet shell it is containing 7 electrons. To get the stability, it gains 1 more electron and becomes F minus. So like this, the atoms becomes cations and anions by losing and gaining electrons. Why all the atoms losing electrons and gaining electrons? Because of to get the octet configuration, right? So here, see, generally helium, neon, argon, krypton, xenon and radon. So these elements are called zero group elements and these are noble gases. So here, when we are observing, except helium, see here, neon, argon, krypton, xenon and radon, all the elements having 8 electrons in the valence shell. So because of containing the 8 electrons, this group is called noble gases, which means they are stable. See, if you have the stable configuration, you need not to participate in any chemical reaction. So that is why these noble gases having less reactive, which means they don't participate in any reaction. And now if you observe here the 1A group, 2A group, 3A group, sodium loses 1 electron, whereas magnesium group loses, 2A group loses 2 electrons. And the third A group loses 3 electrons. Sodium becomes Na plus, potassium becomes potassium plus. In the same way, magnesium becomes Mg plus 2, aluminum becomes Al plus 3. So all the 1A, 2A, 3A group elements are losing electrons. Why they are losing electrons mean to get the octet configuration. When we are observing in this case, the 5A group elements, nitrogen is gains 3 electrons, becomes N minus 3, whereas oxygen gains 2 electrons, becomes O minus 2. Fluorine gains 1 electron, becomes F minus. So here gain of electrons. So if you are observing here, the 1A, 2A, 3A group elements are losing electrons and becomes cations. So see here, Na plus, Ca plus, plus 2, Mg plus 2, Al plus 3. So all these are called cations because they are losing electrons. So they are called metals. So metals means metals having a tendency to become positive ions, which means they are losing electrons and becomes cation. Whereas if you are observing N minus 3, O minus 2, F minus 1, so all these are gaining electrons, which means they becomes non-metals. Non-metals means they are having a tendency to become anions. All these are negative ions. So these are called non-metals. Here the helium, neon, argon, krypton, this group is called noble gases. So I think you have understood well. To get this octet configuration, some elements are losing electrons and becomes unipositive ions or dipositive ions. Finally they become metals. So they are named as metals. Metals having a tendency to become positive ions. Whereas some elements are gaining electrons. Why they are gaining electrons means they are also trying to get the octet configuration, stable configuration, and becomes non-metals. Is it okay? So this electronic theory of valence is mainly explaining this concept. So basing on the noble gases electronic configuration, the remaining elements are also assigned in that way. They are treated as metals and non-metals like this. So noble gases generally possess, except helium, The remaining all noble gases possess 8 electrons in the valence shell. So because of this stable configuration, they are stable. So that's why they are called noble gases or inert gases, which means they are inactive. They are not participating in any chemical changes. So now let us see what is an octet rule. So now, what is an octet rule? A rule which states that an atom must contain 8 electrons in the valence shell to get the stability is called octet rule. So all noble gases except helium are containing 8 electrons in the valence shell. So that is why they are stable. So this is octet rule. Now let us see what is a chemical bond. So chemical bond means if you take any two atoms, so this is atom A and atom B. So in between the two atoms there exists some force of attraction. So because of the force of attraction, the two atoms combines close together and becomes a stable entity. So that is called chemical bond. So why the two atoms comes close together means to become the stable. For example, take if the atom having less electrons to get the stability. If the atom be having more electrons to get the stability. So when the two atoms comes close together by the force of attraction, in between the two atoms there may be the transfer of electrons or the sharing of electrons will take place. Whatever it may be, by transfer of electrons or sharing of electrons, the two atoms become stable itself, which means the two atoms getting octet configuration and become stable. So that is called chemical bond. So there are different types of chemical bonds there. For example, ionic bond is there and covalent bond is there, and coordinate covalent bond is also there. Metallic bond and hydrogen bond. So many types of chemical bonds are there. To explain the stability concept, different types of chemical bonds were introduced. So in your in this contest we will study about ionic bond and covalent bond. So what is an ionic bond? This electronic theory of valence generally explains about two types of bonds. So in that, the first one is called ionic bond and the second one is called covalent bond. Let us see what is an ionic bond first, then we will discuss about the covalent bond. So the scientist called Kossel is proposed the ionic bond. It is formed between the two dissimilar atoms. It is very important point, because in the ionic bond there is a transfer of electrons will take place. How the transfer of electrons will take place ionic bond, I will explain with example. Okay, so it is also called an electrostatic bond and electrovalent bond, because this ionic bond is formed between the two dissimilar atoms. In between the two dissimilar atoms there exists an electrostatic force. So that's why it is called electrostatic bond. And the concept of valency is clearly explained in this bond. So that is why it is called electrovalent bond. And this ionic bond is called ionic bond means it is formed between the ions. So that is why it is also called ionic bond. So electrostatic bond or electrovalent bond, ionic bond, the three names are common. Three names are same. Is it okay? And it is formed between the metals and non-metals mostly. Why this bond is formed between the metals and non-metals, I will explain. For example, take two atoms. So this is atom A and this is atom B. If the atom A is don't having octet configuration and atom B also not having octet configuration, which means the atom A having excess electrons. So to get the octet configuration, the atom A is losing the excess electrons and becomes A plus, which means it is cation, positive ion. See, and if the atom A having less electrons, which means to get the configuration, octet configuration, it requires some electrons. So the atom A is transferring the excess electrons to the atom B. So by transferring the excess electron from atom A to B, then atom A becomes stable by getting octet configuration, and by taking the excess electron from A to B, and B also become stable by gaining octet configuration, and B becomes B minus ion, means anion, negative ion. So in between the two ions there exists a electrostatic force. Because of the electrostatic force only, the two atoms comes close together and becomes a stable compound AP. So this is called ionic bond. Is it clear? So now I will explain this ionic bond with an example. See, the first example is sodium chloride. Take the sodium chloride. So first take sodium. We know sodium having 11 electrons. So configuration is 1s2, 2s2, 2p6, 3s1. So already we discussed that the sodium having one valence electron in the valence shell. Is it okay? So to get the stability, it containing one extra electron. So that is why the sodium loses that extra electron and becomes sodium plus. So it is cation. So by losing the one electron, sodium becomes sodium plus. Take the chlorine atom. So its configuration means it is containing 17 electrons. Configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So if we are observing in this case, the chlorine atom so if you are observing in this case, the chlorine atom requires one electron to get the stability. Because in the outermost shell it contains 7 electrons, to get the stability it requires one more extra electron. So this sodium is giving or donating that electron to the chlorine atom, and chlorine is accepting that electron. So here sodium is a donor whereas chlorine is an acceptor. So in between the donor and acceptor there exists a bond, that is ionic bond. So here the sodium is donating that electron to the chlorine atom, and chlorine is gaining or accepting that electron by gaining that, by gaining that electron, chlorine becomes chlorine minus. So this is anion. So now when the two ions Na plus and chlorine minus, so one is cation and one is anion, in between the two atoms there exists a electrostatic force. So the cations and anions are formed due to the transfer of electrons from some metal atom to non-metal atom, experience the electrostatic forces and get attracted to form a chemical bond. See here, already we discussed sodium is a metal because it is having a tendency to become a positive ion. So generally all the positive ions are metals only. So sodium is a metal. Whereas chlorine is a anion. It is a non-metal. So in between the metal and non-metal, due to the electrostatic force, when the two ions comes close together by transfer of electrons from one to another, there exists a ionic bond. So this is sodium chloride. Like this, the sodium chloride molecule will form by transferring electrons from metal to non-metal. Is it clear? And here, if you see, generally 1A group elements and 2A group elements. 1A group elements are called alkali metals. Just wait, I will. Generally 1A group elements and 2A group elements are called alkali metals, and 2A group elements are called alkaline earth metals. So in between the metals, whereas 7A group elements are called non-metals. So they are called halogens. So in between the metals and non-metals, there exists a bond, ionic bond. So in between the ions it is exist. So that is why it is ionic bond. And here the valency concept is also explained very clearly. So that is why it is called electrovalent bond. So if you see this ionic bond is formed between the metals 1A and 2A group elements and 7A group elements, non-metals, halogens. Let us see one more example. For example, take the magnesium chloride, MgCl2. How MgCl2 will form? Let us see. So magnesium is a metal containing 12 electrons. So configuration is 1s2, 2s2, 2p6 and 3s2. So in the outermost shell it contains 2 electrons. By losing the 2 electrons, magnesium becomes Mg plus 2 cation. Whereas take the chlorine atom, already we know chlorine having 1s2, 2s2, 2p6 and 3s2, 3p5 configuration. So chlorine is ready to accept 1 electron. But here in this case the magnesium is losing 2 electrons and becomes Mg plus 2. So here 2 electrons are there. But here chlorine is only ready to take 1 electron because chlorine only requires 1 electron. In the outermost shell it contains 7 electrons, right? So that is why 2 chlorine atoms will join with magnesium, because that is why the formula is MgCl2, which means 1 magnesium atom and 2 chlorine atoms will participate because magnesium is donating 2 electrons. Is it clear? So the chlorine atom will take 1 electron and another chlorine atom will take another electron. So like this, the 2 chlorine atoms take the 2 electrons which are donated by the magnesium and becomes 2Cl minus. So like this, Mg plus 2 plus 2Cl minus gives rise to MgCl2. So like this magnesium chloride will takes place. So take another example, AlCl3. So here also the aluminum is a metal. It is containing, its configuration is 1s2, 2s2, 2p6 and 3s2, 3p1. So it requires 3 electrons in the outermost shell. So aluminum becomes Al plus 3 by losing 3 electrons. So here to take the 3 electrons, 3 chlorine atoms will join because 1 chlorine atom is capable to take 1 electron only. So that is why here 3 chlorine atoms will take the 3 electrons which are donated by the aluminum and becomes 3Cl minus. So like this, Al plus 3 and 3Cl minus becomes AlCl3, aluminum chloride. So this is what the ionic bond. Let us see one more example. So take Na2O. So disodium monoxide. How the disodium monoxide will form, let us see. So if you are taking Na2 sodium atom, we know that sodium 1s2, 2s2, 2p6 and 3s1. So sodium becomes sodium plus by losing 1 electron. Here oxygen atom is 8 containing 1s2, 2s2, 2p4. So here in this case, in the outermost shell it contains 6 electrons. To get the stability it requires 2 electrons. So here the single sodium atom can donate only 1 electron. But the oxygen is not satisfying by taking the 1 electron. So that is why here 2 sodium atoms will participate. So the 2 sodium atoms will donate 2 electrons and becomes 2Na plus. So the oxygen atom will take the 2 electrons and becomes O minus 2. So the 2Na plus and O minus 2 will form Na2O. So like this disodium monoxide will form. So these are the examples for ionic bond formation. Okay, now the arrangement of ions in ionic compounds. So how the ions, cations and anions, how they are arranged in the ionic compounds. Let us see. So we have already discussed sodium chloride, magnesium chloride, aluminum chloride. See, generally the ionic compounds are mostly solids, which means crystals. Because in between the two atoms there exists a strong force of attraction, that is nothing but the electrostatic force. Because of that attractive force, most of the ionic compounds are crystals only. So now, how the cations and anions of the ionic compounds can exist in the solids? Let us see. Take the example sodium chloride. So in the sodium chloride, two types of ions are there, Na plus ions and Cl minus ions. So cation, anion. So now, do you think that the pairs of Na plus and Cl minus as units would be present in the solid crystal? But if you think so, it's not correct, because there exists in between the two ions there exists a electrostatic force, right? But this electrostatic force is non-directional. See, very important point. Because of it, it is not possible for one sodium plus ion is attacked or attracted by the chlorine ion, whereas the chlorine ion is not attracted by the sodium ions. Then how the structure will form? So depending on the two factors, especially depending on the size as well as charge. So basing on the two factors, generally the number of how the number of oppositely charged ions get attracted by it, but in a definite number. So basing on that size and charge, there exists the structure of that crystalline. If you take the sodium chloride, take this example. So generally in sodium chloride, so each sodium atom is surrounded by the 6 chlorine atoms, and each chlorine atom is surrounded by the 6 sodium atoms, which means sodium ion is surrounded by the 6 chlorine ions, whereas chlorine ion is surrounded by the 6 sodium ions. How? Let us see. If you take this, this is NaCl structure. So here the blue color dots, see, these are chlorine ions and red colors are sodium ions. So NaCl is, the structure of NaCl is FCC. FCC means face centered cubic lattice. So, which means the NaCl should possess the face centered cubic lattice structure. So here, if you observe here, each chlorine atom is surrounded by 6 sodium ions. In the same way, each sodium ion is surrounded by 6 chlorine atoms, 6 sides. So that is where the structure is FCC, face centered cubic lattice, which means each sodium ion is surrounded by 6 chlorine atoms, chlorine ions. In the same way, each chlorine ion is surrounded by, if you take, see here 1, 2, 3, 4, 5, 6, like this. So every chlorine ion is surrounded by 6 sodium ions, and in the same way every sodium ion is surrounded by 6 chlorine ions. So like this, the crystalline structure of sodium chloride is face centered cubic lattice. So here the number of ions of opposite charge that surround in given in charge is known as the coordination number of that given ion. So in your examination there will be a question. For example, in sodium chloride crystal, the coordination number of Na plus ion is 6, and the coordination number of Cl minus ion is also 6, because coordination number means nothing but the number of ions of opposite charge that surround a given ion of given charge is known as the coordination number. So very important, coordination number. Coordination number means the given charge is surrounded by how many opposite charge ions. So here in case of sodium chloride, sodium is surrounded by 6. In the same way, chlorine ion is also surrounded by 6. So this is the arrangement of ions in sodium chloride. So one example is enough. And now let us see what are the factors that are affecting the formation of cation and anion. See, in case of sodium chloride we discussed there is a formation of cation and anion, and then there exists a bond between the two ions because of the electrostatic force. And now what are the factors which are affecting the formation of cation and anion? Let us see. So here in sodium chloride, let us take sodium chloride. First we discussed, first cation is formed. This is cation, right? Then after chlorine minus ion is formed. This is anion. So by forming the cation and anion, in between the two ions there exists a electrostatic force. So because of this electrostatic force, the two ions will combine and gives the neutral compound NaCl, stable compound. That is what the formation of the ionic bond, right? And now what are the factors which are affecting the formation of cation and anion? See, already in the classification of filament we discussed what are metals and non-metals. See, and what is the metallic character and non-metallic character we discussed in the topic. And now let us recall it. So cation means, if you observe it, this is a positive ion, right? Positive means it is containing the positive charge. So that is why this is positive ion or cation. Anion means definitely negative ion. right? So what are metals? Already we discussed. The ionic bond is formed between the metals and non-metals. Earlier we discussed it is formed between the metals and non-metals. Which means metals means having a tendency of losing electrons to attain the octet in their valence shell, and this property is called metallic nature or metallic character. Generally all metals having a tendency to become cations, which means positive ions. For example, magnesium plus 2, aluminum plus 3. So all these are metals only because they are trying to lose electrons and become positive ions. So this character is called metallic character. And what is non-metallic character? See, non-metallic character means the tendency of gaining electrons. So anions are non-metals. Chlorine minus, bromine minus, fluorine minus, nitrogen minus 3, oxygen minus 2. So all these are called anions because they try to gain electrons from the cations. So this nature is called non-metallic nature. Non-metallic nature means they try to gain electrons to get the octet configuration only. See, whether the metals and non-metals or the cations or anions, both are try to gain electrons or try to lose electrons because of getting octet configuration only. So to getting the octet configuration, or in other words to getting the stability concept, the formation of cations and anions will be there. So this is called non-metallic nature, right? And now here we have to know some more points regarding this ionic bond. See, for example, already we know metals and non-metals. In between metals and non-metals there exists an ionic bond. So ionic bond is formed between the atoms of elements with electronegativity value is greater than or equal to 1.9, which means ionic bond is formed between the atoms of elements with electronegativity difference equal to or greater than 1.9. So you have to remember the point, which means if the electronegativity value is greater than 1.9, there will be less chance to form ionic bond. And also the ionic bond formation will be affecting some points are there. For example, the cations means which means having a tendency to lose electrons. Anions means having a tendency to gain electrons. These cations and anions depend on the some factors. So let us see. The first factor is atomic size, and second factor is ionization energy. Third factor electron affinity, and fourth factor electronegativity. So regarding these all factors, just wait. See, already we discussed very clearly about what is atomic size and what is ionization energy, what is electron affinity, and what is electronegativity. So we are clearly discussed these topics in the previous topic, that is classification of elements, right? So here we have discussed all the topics. Now how the formation of cations and anions are affecting regarding these factors. So which means if we know that, So the atom, if the atomic size is more, see, if the atomic size is more, then the ionization energy will be less. Obviously electron affinity will also be less, and electronegativity will also be less. Then there is a possibility to form cations. Is it okay? How the cations will form means, if atomic size is more and electron affinity, electroionization energy and electronegativity, all the factors are less, which means the atoms of element with low ionization energy, low electron affinity and high atomic size and low electronegativity, then only the cations will form. And how the anions will form? That is quite reverse, which means the atoms of element with high ionization energy and with high electron affinity and small atomic size and high electronegativity, then there is formation of anions. So you have to remember this point. Okay, so this is all about regarding the ionization and ionic bond formation, and what are the factors affecting on the formation of ionic bond, and how the cations and anions will be arranged in the crystalline. So all the topics were completely explained in this video. In the 1916, G.N. Lewis he proposed that atoms of some elements could not, which means some atoms of elements could achieve an octet rule, so without the transfer of electrons between them. Then how can then they attain the octet configuration? So already we discussed in the ionic bond, there is a transfer of electrons is there. So because of transfer of electrons only there exists a bond formation, and they can attain octet configuration in their valence shell. But the covalent bond is proposed by the scientist called G.N. Lewis in the year 1960. He told that without a transfer of electrons between the two atoms, but they can get the octet configuration by sharing of electrons. It is very important. So the sharing of electrons takes place. Here electrons meet not all the electrons, only valence electrons. By sharing of valence electrons with one or more atoms, there exists a bond. So that is nothing but covalent bond. So here the covalent bond means the electrons shared between the two atoms belong to the both atoms and sharing of electrons between them, leading to the formation of a chemical bond known as the covalent bond. So here we have to remember one more point. In the ionic bond we discussed that this ionic bond is formed between the two dissimilar atoms. But here the covalent bond is formed between mainly in similar atoms. So for example H2, F2, N2, O2. So in between hydrogen, fluorine, nitrogen, oxygen molecules, there exist two atoms, two hydrogen atoms. So two fluorine atoms, two nitrogen atoms and two oxygen atoms. So these are similar atoms. Is it okay? In between the two similar atoms, there exists a octet configuration by sharing of valence electron. So that is nothing but the covalent bond. And now Let us see one example. So for example, take fluorine atom, fluorine molecule. So how the covalent bond is formed in between the two fluorine atoms. So fluorine molecule means two fluorine atom, there is a bond. So it is a stable molecule, no doubt. Each fluorine atom, so generally we know fluorine's atomic number is 9, configuration is 1s2, 2s2, 2p5. So if you observe here, in the outermost shell it contains only 7 electrons. So to get the octet configuration it requires 1 electron. Take another fluorine atom. So here also same thing. It is also having 1s2, 2s2, 2p5 configuration. So if you see, it contains only 7 electrons in the outermost shell. To get the octet configuration, it requires 1 electron. So here, by mutual sharing of valence electrons in two fluorine atoms. So I will write here the Lewis dot structure. So this is one fluorine atom. It will contain total number of 7 electrons. So take another fluorine atom. So it is also containing 7 electrons. So by mutual sharing of these two fluorine atoms, so the first fluorine atom will give 1 electron and the second fluorine atom is also sharing 1 electron. So by sharing this 1 electron from the other fluorine atom, so the first fluorine atom getting octet configuration by sharing the 1 from the other fluorine atom. So it is stabilized because 2, 4, 6, 8 electrons. So the first fluorine atom will get the octet configuration. If you observe here, the second fluorine atom is also same. It is also by mutual sharing 1 electron in each case. So it is also 2, 4, 6, 8. So the second fluorine atom is also getting 8 electrons, which means it is also stable. So like this, in between the two fluorine atoms, there is a mutual sharing of electrons. By mutual sharing of electrons, there is a formation of a bond, and that bond is called covalent bond. So if you observe here 2 electrons will be shared, 1 electron in each case. So this is fluorine atom. And now let us see some more examples. Take another example. So here, see here, in case of fluorine, I will explain once again. So this is fluorine atom. 2, 4, 6 and 7. Take another fluorine atom. 2, 4, 6. So like this, there is a bond, and this bond is called covalent bond. So if you observe here, the chemical bond between the two atoms by mutual sharing of a pair of valence shell electrons. So here the sharing of electrons are valence electrons only, so that both of them can attain octet configuration in their valence shell is called covalent bond. So here if you observe here covalent, so here co is used to indicate when things are equal or joined. Covalent means here coexist, for example cooperate. So here each atom contributes 1 electron from the valence shell for bonding. So that is why the name is given as covalent, which means equal valence electrons contribution here. Is it okay? And for example, so here one bond is formed. One bond means 2 electron, sharing of 2 valence electron. So this is called single bond. If 2 bonds are there, then that is called double bond. If 3 bonds are there, then that is called triple bond. So now let us see how the double bond and triple bond also form. Take one more example. For example, oxygen molecule. So if you see the oxygen molecule, it contains 8 electrons. So 1s2, 2s2, 2p4. So in the outermost shell it contains 6 electrons. To get the octet configuration, it requires 2 electrons. So I will draw the structure of oxygen. So 1, 2, 4, 6, like this. Take another oxygen atom, it is also containing the same pattern. So 2, 4, 6, which means each oxygen atom is having 6 electrons in the valence shell. Is it okay? So by sharing 2 electrons in each case, so the first oxygen atom will give 2 electrons for bond formation, and here the second oxygen atom will also give 2 electrons. It is also containing 6 electrons. So here by sharing of 2 electrons, the oxygen molecule will form, because by taking the total number of 8 electrons, the first oxygen is stable. By taking the total number of 8 electrons, the second oxygen is also stable. So here like this the oxygen molecule will form. Here double bond is there, because here 2 pairs and each oxygen atom is sharing 2 electrons in each case. Why it is sharing 2 electrons means, because to get the octet configuration it requires 2 electrons. That is why each oxygen atom is giving or sharing 2 electrons in each case. So in case of oxygen, double bond is formed. And now let us see one more example. So take nitrogen atom. So nitrogen number is 7, atomic number configuration is 1s2, 2s2, 2p3. So in the outermost shell it contains 5 electrons. To get the octet configuration it requires 3 electrons. So write the Lewis structure of nitrogen atom. So nitrogen 5 electrons it contains. So 2, 4, 5. Take another nitrogen atom. It is also containing 2, 4, 5. So now when the two atoms combines, each nitrogen atom requires 3 electrons, right? So that is why each will donate 3 electrons, or each will share 3 electrons. So the first nitrogen atom will give 3 electrons, and the second nitrogen atom will also give 3 electrons, like this. So in between the two nitrogen atoms, triple bond is formed. Is it okay? Because each nitrogen atom is sharing 3 electrons. So like this, by sharing the total electrons, the nitrogen will be stable, and by sharing the total electrons, and second nitrogen will be stable. So like this, in between the two nitrogen atoms there exists a triple bond. So once again I will draw the structure, Lewis dot structure for nitrogen atom. So first nitrogen atom, total number of 5, and second nitrogen atom, so finally when 2 combines, so in between the two nitrogen atoms there exists a triple bond, like this. So this is the nitrogen molecule. And now let us see one more example. For example, take methane, CH4 molecule, methane. So how many covalent bonds are there in between methane? Let us see. So we know methane means CH4, one carbon atom, and 4 hydrogen. So here in case we discussed already in covalent bond, it is sharing of electrons takes place in similar atoms. But here in case of methane, carbon is different atom and hydrogen is also different atom, which means the covalent bond is also formed between the two dissimilar atoms. But here the transfer of electrons will not take place. Here only the mutual sharing of electrons will take place. So you have to remember that point. In case of the ionic bond, the ionic bond is always formed between the two dissimilar atoms because of the transfer of electrons will take place. But here in case of methane, the carbon is different and hydrogen is different. But in between the two different atoms also covalent bond will form. But here also the mutual sharing of valence electron takes place. And how it is takes place, let us see. We know carbon having 6 configuration, 1s2, 2s2, 2p2, right? So in the outermost shell it contains only 4 electrons. So to get the octet configuration it requires 4 more electrons. We know it very well. So let us take hydrogen atom. We know hydrogen having only 1s1 configuration because it is containing only 1 electron. So it won't get the 8 electrons because it is hydrogen, it contains only one shell, one main shell. So that is why hydrogen getting stability by taking 1 electron. So carbon atom, it contains 4 electron. If you take 4 hydrogen atoms, 1, 2, 3 and 4 like this. So what happened? The carbon atom is containing 4 electron like this, and hydrogen atom also, each hydrogen is also sharing 1 electron in each case like this. Is it okay? So if you observe here, by sharing these 2 electron, the hydrogen will stable. By sharing these 2, this hydrogen will be stable. By sharing these 2, this hydrogen will be stable. And by sharing these 2, this hydrogen will be stable. And overall by taking all 8 electrons, the carbon will be stable. So like this, in between CH4, there exist 4 covalent bonds. How many bonds are there? 4 covalent bonds. Because in methane, carbon is sharing 4 electrons and 4 hydrogen atoms are sharing 4 electrons, 1 in each case. So like this, there are total number of 4 covalent bonds are formed between the methane molecule. So this is the formation of methane. So if you write the structure like this, you will also get the same hydrogen like this. See, if you draw the structure, the carbon is donating 4 electrons. So like this is the formation of methane. And now let us see one more example, that is ammonia. So let us take ammonia, NH3. So in the same way, if you already we discussed methane. In methane, in between the carbon and hydrogen, total number of 4 covalent bonds are there, right? And now let us see how many covalent bonds will take place in ammonia. Already we know nitrogen atom having 1s2, 2s2, 2p3. So it gets 5 electron. It requires 3 more electrons, right? So nitrogen atom contains 5 electrons in the valence shell. So 3, 4, 5. And each 3 hydrogen atoms are there. So each hydrogen atom is containing 1 electron in each case. So first one, second one, and third one. By sharing total number of electrons, so the nitrogen will require only 3 electrons. Is it okay? So that is why the nitrogen will share 3 electrons like this. And so this is nitrogen atom. It contains total number of 5 electrons. So here this is hydrogen atom. It will share 1 electron. Sorry. Here only 3 hydrogens are there. So first hydrogen, second hydrogen, and third hydrogen. So if you observe here one bond, second bond, third bond. So if you are observing in between the nitrogen and hydrogen, only 3 covalent bonds will form. But the 2 electrons are remained as lone pair of electrons, and we will discuss what is lone pair, all those things in the next class. Okay. So if you observe in between nitrogen hydrogen, in ammonia in between nitrogen hydrogen, there are total number of 3 covalent bonds will form. Because by sharing these 2 electrons, hydrogen will be stable. And by sharing the total 8 electrons, nitrogen also will be stable. So like this, in ammonia, in between the nitrogen hydrogen, there are total number of 3 covalent bonds will be formed. And what about this lone pair of electron? Why it is not sharing or participating in the bond? We will discuss in the next class. And now let us see one more last example about covalent bond, that is H2O, water molecule. So water molecule, let us see how many covalent bonds in between the water molecule. So here 2 hydrogen atoms and 1 oxygen atom, H2O, right? So each hydrogen is containing 1 electron in the outermost shell. And we know oxygen is containing 6 electron in the outermost shell, because its configuration is, oxygen's configuration we discussed already, 1s2, 2s2, 2p4. So if you see in the outermost shell, it contains 6 electron. To get the configuration, it will require 2 more electrons. So if you take the oxygen atom, it contains 2, 4 and 6 like this. So this is oxygen atom. But if you see, oxygen atom only requires 2 electrons, right? So oxygen will share 2 electrons, which means 1 electron to each hydrogen atom. So this is oxygen atom. So it contains 2, 4, 5 and 6 electrons like this. And hydrogen atom, this is hydrogen atom, and this is one more hydrogen atom. So it will share 1 electron in each case. So like this, by sharing takes place, there is a one single bond and single bond. So like this, in between the two oxygen, in between the oxygen hydrogen, 2 covalent bonds will form. Is it okay? See, by sharing 1 electron, this hydrogen will stable, and this hydrogen will also be stable. And 2, 4, 6, 8, by sharing total electrons, this oxygen atom will be stable. So like this, there exists a stable molecule, H2O, water molecule. So here also in this case, the 2 pairs of electrons are remained. So those are called lone pair of electrons. We will discuss this lone pair of electrons in the next class. So already in case of ammonia also there is a 1 lone pair of electron. But in case of water molecule there are 2 lone pairs of electrons. So why these lone pair of electrons are not involving in the bond, we will discuss in the next video. So in the water molecule, in between the oxygen and hydrogen, there are 2 covalent bonds are formed. Okay. We have to know one more small concept, that is covalency. So what is covalency? The total number of covalent bonds that an atom of an element form is called covalency. So by the atom, how many covalent bonds will form, that is called covalency. So you have to remember this point just. And now let us see one more concept. So what is bond length? So generally bond, we have discussed already covalent bond. So in between hydrogen, one single covalent bond. In between methane, so there are 4 covalent bonds. In between NH3, there are 3 covalent bonds. If you see the nitrogen, there are 3 covalent bonds. So what is bond length? So bond length is also called bond distance. So bond distance means it is an equilibrium distance between the nuclei of 2 atoms which form a covalent bond. If you take the hydrogen atom, so in between the 2 hydrogen atom, there exists a single covalent bond, right? One single covalent bond is there in between the 2 hydrogen atom. So H2 is a molecule. By forming single covalent bond between the 2 hydrogen atoms, so the distance between the nuclei of 2 atoms, so that is called bond length or bond distance. Is it okay? Generally it is given or expressed in the units of nm. nm means nanometer or angstroms, we know it angstroms. So this is the unit for the bond length. And what are the bond length of some elements? For example, if you see the hydrogen bond length, that is 0.74 angstroms. So you just keep the values, that's enough. You have to remember that. If you see in case of fluorine, so 1.44 angstrom bond length. In case of chlorine, in between chlorine, that is 1.95 angstrom. You just simply remember the values, it is provided in your textbook. See, in case of bromine, the bond length is 2.28 angstroms. So if you see in case of carbon and hydrogen, in case of CH4, that is 1.10 angstrom. So this is bond length. And one more concept is that is bond energy. Let us see. So what is bond energy or bond dissociation energy? Which means the energy needed to break a covalent bond between 2 atoms of a diatomic covalent compound in a gaseous state. So very clear, if you take nitrogen or hydrogen or bromine or fluorine, so in case in between the 2 nitrogen atoms, there are 3 covalent bonds will there. So to break that bond, covalent bond, you need some energy. So that energy is called bond energy or bond dissociation energy. Is it okay? So generally it is expressed in kilojoule per moles, bond dissociation energy. So this is all about bond energy and bond length. Finally, we have to know what are the limitations of or drawbacks of the electronic theory of valence. So this is very important theory we discussed about. This theory gives so many concepts regarding the chemical bond. So by the 2 scientists called Kossel and Lewis, they proposed a theory called electronic theory of valence. In this theory we studied about what is an ionic bond and what is a covalent bond. It explains very clearly about the bond formation between so many molecules. Now it is also having some drawbacks. So the first drawback is that, see, already we discussed the bond energies and bond lengths of some molecules. So when a covalent bond is formed between any two species, for example in between hydrogen or fluorine or oxygen, so the bond length and bond energies are expected to be same because the covalent bond is between the two similar atoms. So it results a mere sharing of two identical electrons. But practically the bond length and bond energies are not same. So that is the first drawback. It is not explained why it is different. And there is a second drawback is there. This theory could not explain the shapes of molecules. So that is one more drawback. And there is also one more drawback. See, in case of beryllium chloride, the bond angle is 180 degree. In case of BF3, the bond angle is 120 degree. It couldn't explain, or it fails to explain the shapes of molecule, how the molecules will exist in this shape. So these are all about the drawbacks of the electronic theory of valence. So to overcome the drawbacks, one more theory will come forward to explain all the concepts. So that is called Weissport theory, which means valence shell electron pair repulsive theory. We will discuss this theory in the next video. Thank you.